need to expose different API endpoints based on environment without duplicating your entire server setup. You'll see how FastMCP's tag filtering works with server composition to dynamically include or exclude tools when mounting subservers. We'll create a production-ready API server, then mount it with environment-specific tag filters so only the appropriate endpoints are exposed. Import Asyncio. From FastMCP, import FastMCP, client. Create a subserver with tools tagged for different environments. API server equals FastMCP. Name equals API server. At API server, tool tags equals production. Def prod endpoint, SDR. A production-ready endpoint. Return production data. At API server, tool tags equals development. Def dev endpoint, SDR. A development-only endpoint. Return debug data. Mount the subserver with production tag, filtering at parent level. Prod app equals FastMCP. Name equals production app. Include tags equals production. Prod app. Mount API server prefix equals API. Test the filtering. Async def test filtering. Async with client prod app as client. Tools equals await client list tools. Print available tools. T name for T and tools. Shows API prod endpoint. The API dev endpoint is filtered out. Calling the filtered tool raises an error. Try. Await client call tool. API dev endpoint. Accept exception as E. Print F filtered tool not accessible. E. If name equals main. Asyncio, run test filtering. This demonstrates recursive server composition with tag-based filtering, a pattern for building modular MCP applications where parent servers control child component visibility. The concept combines hierarchical server mounting with declarative tagging, letting you expose or hide functionality at different levels of your application stack. What makes this distinctive is the ability to enforce global policies, like environment-specific tool availability, without modifying the underlying servers. The pattern works by establishing a live delegation chain where parent servers recursively apply their tag filters to all mounted components. When a client requests tools, the parent server first filters its own components, then delegates to child servers while maintaining the same filter criteria. This creates a unified access control layer that remains consistent regardless of how servers are composed, whether through static imports or dynamic mounting. This approach solves the problem of environment-specific configuration in distributed systems, where you need to expose different capabilities to production versus development clients. It's particularly valuable for microservices architectures or plugin systems where you want to maintain a single code base but control feature availability at deployment time. The trade-off is slightly increased complexity in server composition, but the benefit is centralized control over tool exposure across your entire application hierarchy. Let's break it down. Import Asyncio. From FastMCP, import FastMCP, client. Imports Asyncio for running async code and client for connecting to FastMCP servers. These are the core dependencies for building and testing AI-callable tool systems. Create a subserver with tools tagged for different environments. API server equals FastMCP. Name equals API server. This initializes a FastMCP subserver named API server that will host environment-specific tools. The subserver pattern enables modular organization, letting you group related tools and apply different configurations at the parent level. This separation of concerns allows selective exposure of tools based on deployment context. At API server, Tool tags equals production. Def prod endpoint, SDR. A production-ready endpoint. Return production data.
This defines a production-only tool using FastMCP's tagging system. The tags equals production parameter restricts this endpoint to environments where production tools are explicitly included, enabling environment-specific tool filtering. The decorator pattern here creates an AI-callable function while maintaining clean separation between development and production capabilities.
At API server, tool tags equals development. Def dev endpoint, SDR. A development-only endpoint. Return debug data.
This defines a development-only tool using FastMCP's tagging system. The tags equals development. Metadata ensures this endpoint is automatically filtered out when the parent server restricts access to production-tagged tools only. This pattern enables environment-specific tool exposure without code duplication.
Hash mount the subserver with production tag, filtering at parent level. Prod app equals FastMCP. Name equals production app. Include tags equals production. Prod app, mount API server prefix equals API.
This creates a parent FastMCP server with tag-based filtering, only exposing tools marked with production. The mount operation attaches the API server under the /API prefix, enforcing the parent's tag rules on all child tools. This is the composition pattern for environment-specific tool exposure. The parent server controls which tools are visible to clients.
Hash test the filtering. Async def test filtering. Async with client prod app as client. Tools equals await client list tools. Print available tools. T name for T and tools. Hash shows API prod endpoint. Hash the API dev endpoint is filtered out.
This verifies the tag-based filtering works as expected. Using the Client Context Manager, it lists available tools to confirm only production-tagged endpoints appear, demonstrating the parent-level include tags filter in action. The test pattern ensures the filtering logic prevents access to development tools in production.
Try. Await client call tool, API dev endpoint.
This intentionally attempts to call the filtered-out development endpoint. The expected failure demonstrates FastMCP's tag-based filtering in action, proving the production environment only exposes approved tools.
If name equals main. Asyncio, run test filtering.
This is Python's standard entry point guard. It ensures test filtering only runs when this script executes directly, not when imported as a module. The asyncio, run, handles the async event loop execution for our test function. Tag-based filtering pattern. FastMCP's recursive tag filtering lets you expose different toolsets to different clients while maintaining a single code base, with parent servers enforcing global policies that override child configurations. A tool excluded by parent-level tag filters becomes completely invisible to clients, not just inaccessible. This approach eliminates environment-specific code duplication while preserving strict access control.
The server that hides its tools reveals its true power.